Okay, in this video we want to find the general solution for this, and by doing that we need to get eigenvalues and eigenvectors. And so let's get started. So first we will say that this will be 3 minus r, then we have -1, 6, and -2 minus r is equal to 0. For eigenvalues, we always say that this line will be minus r, and this will also be minus r, and this diagonal will remain the same. And so next we multiply this diagonal, and we would get 3 minus r times -2 minus r minus parentheses -1 times 6 is equal to 0. And so we need to multiply this out and expand it. And we would get, so 3 times -2 is -6. 3 times -r is -3r. -r times -2 would give us plus 2r. And -r times -r would produce plus r squared. So minus is positive, so +1 times 6 is plus 6 is equal to 0. And so next we will group and then factor out. So r squared minus 3r plus 2r would be minus r. Minus 6 plus 6 would be 0. So is equal to 0. We factor out an r, and we would get r minus 1 is equal to 0. And so our two roots would be r is equal to 0 or r is equal to 1. And so these two values are our eigenvalue. Eigenvalue. And now we want to get the eigenvector. And so now we will get the eigenvectors for both r is equal to 0 and r is equal to 1. So first we will say for r is equal to 0. And so essentially what we're going to do to say for r is equal to 0 is plug 0 back in for r. And so it's going to be the same because 0 is not going to do anything. So 3, -1, 6, and then -2. And so we'll say that now. So we would get 3 minus 1, 6 minus 2. And we want to clear out some terms. And so we'll use row reduced echelon form. And so if we say r2 is equal to 3r2 plus r1, this term will be eliminated because we would get, so first term r1 would remain the same, but r2, so what we're going to do here is multiply this r2 by 3, so -3, -6, and then we'll add r1, this line. So -3 plus 3 is 0, -6 plus 6 is also 0. And next we're going to want to simplify. If we say that r1 is equal to 1/3 r1, we would get 1, 2, 0, 0 like this. And therefore we can say that, so therefore v1 is equal to minus parentheses 2v2. So v1 is equal to minus 2v2. And so our eigenvector would be, so we plug in a value for v2. If v2 is 1, then we would get if v2 is 1, then v1 would be -2. Or you can think about it this, if v1 is -2, we divide by -2, we get v2 would equal 1. And so this is our eigenvector for r is equal to 0. And so next we're going to want to get the other eigenvalue and get the eigenvector of it. And so just to a recap, we remember the other eigenvalue was r is equal to 1. And so we will plug in 1 for r. So 3 minus 1 is 2. -2 minus 1 is -3. And so we'll do that for to get the last eigenvector. And so we say for r is equal to 1, we would get 2 minus 1, 6 minus 3. And we will do row reduced echelon form. And so we want to clear this term out. We can do that if we say that R2 is equal to 2R2 plus R1. So negative 2 plus 2 is 0. Negative 6 plus 6 is also 0. And so we would get 2, 6, 0, 0. And we can further simplify this a little bit if we say that R1 is equal to 1/2 R1. And so we would get 1, 0, 3, 0 like this. And so therefore we can say that our eigenvector would be, so V1 is equal to minus parentheses 3V2. So V1 is equal to minus 3V2. And that means if V2 is 1, then V1 would be negative 3. Or you could think about it this way. If V1 is negative 3, we divide by negative 3. That means V2 is 1. And so this is our eigenvector for the eigenvalue of R is equal to 1. And now we're almost there. We want to get the general solution. And the general solution is a combination of both of the eigenvectors that we just found. And so we can say that it would be C1, and the first eigenvector we said was this. It was for R is equal to 0, and the eigenvector was negative 2, 1. And so it would be C1 e raised to 0t. The eigenvalue was 0, and the eigenvector was negative 2, 1, plus C2 e raised to, the eigenvalue here was 1, so t, and the eigenvector was negative 3, 1. And so we can actually simplify this a little bit. We know that e raised to 0 is 1, so our final answer could be this. C1, the eigenvector was negative 2, 1, plus C2 e raised to t, and the eigenvector was negative 3, 1. And so we just need to box this answer in. And so this is the general solution. And that's all we need to do.